span the vectors left contain V1, V2, and V3. Where V1 is equal to 2, 1, 0, 3. V2 has components 3, negative 1, 5, 2, and V3 has components negative 1, 0, 2, 1. Okay? So first step class is to write the equation. Okay? That will help us in defining if this vector W is one given set S or the set of vectors V1, V2, V3. Okay? So we have now K1, V1 plus K2, V2 plus K3, V3 is equal to V. Okay? We have here three unknowns class because there are three vectors. So that depends on the number of unknowns, okay, on the number of vectors. So we have now K1 multiplied by V1, which is 2, 1, 0, 3. Then K2 multiplied by 3, negative 1, 5, 2. And then we have plus K3 multiplied by negative 1, 0, 2, 1. Okay? Where you have plus the vector W. Sorry, it should be vector W plus. However, we have now 2, 3, negative 7, 3. Okay? Then, after setting up the equation, we go down in setting up the matrix. Okay, so where we have plus, the first column of the matrix will be the components of your vector 1 as column 1. So 2, 1, 0, 3. Then we have second column plus will be the vector 2 components 3, negative 1, 5, 2. And then we have negative 1, 0, 2, 1 for the third column class. And then for the fourth column, we have 2, 3, negative 7, 3. Okay? Then class check out your matrix. So we're going to transform the matrix into our RDF form. That is solving for K1, K2, and K3. Okay? So first step for the RDF is the leading one. So we can have leading 1 plus by interchanging rows 1 and row 2. Okay? So that we have now the corresponding matrix 1, negative 1, 0, 3. Then we have 2, 3, negative 1, 2. Then we have 0, 5, 2, negative 7. And then we have 3, 2, 1, 3. Okay? Let us now transform first column class, except of course the leading one as the zeros. Okay? So let's start with 2 and then followed by 3. Okay? So we will make this of row 1, multiply this by 2, then subtract it to row 2. Okay? What about class row 4? Where P2 becomes 0, multiply this by the leading one by 3, then subtract it to R4. Okay? Next one class. Let us now compute for the resulting matrix. So we have now 1, negative 1, 0, 3. Then for the second row class, 2 times 1, 2 minus 2 will be 0. 2 times negative 1, negative 2 minus 3 will be negative 5. 2 times 0 minus negative 1 will be 1. 2 times 3, 6 minus 2 is 4. Okay? What about the third row class? There's no transformation here because we have already 0 on this particular column class, which is column 1, right? So we have 0, 5, 2, negative 7. Okay? Then we go down to third row. So we have 3 times 1, 3 minus 3, 0. 3 times negative 1, negative 3 minus 2, negative 5. 3 times 0, 0 minus 1, negative 1. Then 3 times 3, 9, minus 3, that is 6. Okay? Then we go now to the leading one in second column class. Okay, so we can now divide row 2 by negative 1. For multiply this by 1, right? So what is now the solving matrix? 1, negative 1, 0, 3. Then we have 0, 1, negative 1, 50. Then negative 4 fifths. Then we have 0, 5, 2, negative 7. Then 0, negative 5, negative 1, and 6. Okay? So next class, to make the other column, the other members of the second column class to make 0 or to become 0. Okay? So what is then our operation class for row 1? So it will be R1 plus R2. You have 81 in your second column class, which is okay. Then you have 5 R2 minus R3. Then you have 5 R2 plus R4. Okay? So let us now compute for the resulting matrix using the RREF. So what do we have now? Okay, 1 plus 0 is 1, then negative 1 plus 1 is 0, then 0 plus negative 1 fifth, negative 1 fifth. Then you have 3 minus 4 fifths, that will be 12 over 5. Okay, next one class. You have now 0, 1, negative 1 fifth, and then negative 4 fifths. Okay, what about now the third row? Using this operation, 5R2 minus R3, so 5 times 0 minus 0 is 0. 5 times 1, 5 minus 5, 0. 5 times negative 1 fifth plus will give us negative 1 minus 2, negative 3. 5 times negative 4 fifths will give you negative 4 plus 7, positive 3. Okay? Then what about class the last row? So 5R2 plus R4. Okay? So 5 times 0, 0 plus 0, that will give you 0. 5 times 5 plus negative 5, 0. 5 times negative 1 fifth, that is negative 1 plus negative 1, that will give you negative 2. Then 5 times negative 4 fifths is negative 4 plus 6, positive 2. Okay? Next class. Yes. Okay, let's now proceed class with leading one in the third row, right? So I will multiply class R3 by negative 1/3, then R2, or I should say R4 times negative 1/2, okay? Then what is the resulting matrix? So we have 1, 0, negative 1 fifth, 11 over 5. Then 0, 1, negative 1 fifth, negative 4 over 5. Then we have here 0, 0, 1, negative 1. Because this is to be multiplied by negative 1/3, right? Then we have also 0, 0, 1, negative 1. Okay? Next thing to do is now to make. So let's have this class to become 0. So what is now our operation? It will be R1 plus 1 fifth R3, because we are leading one in the third row. Then R2 plus 1 fifth R3, then R3 minus R4. Okay, so what is now the resulting matrix? So we have 1 plus 1 fifth times 0 is 1, then 0 plus 1 fifth times 0 is 0, then negative 1 fifth plus 1 fifth times 1 is 0, then 11 over 5 minus 1 over 5 is 10 over 5, right? Or this is now 2. Okay, next one. R2 plus 1/5 R3. So 0 plus 1/5 times 0 is 0. Then 1 plus 1/5 times 0 is 1. Then we have negative 1/5 plus 1/5 times 1 is 0. Then negative 4/5 minus 1, that will be minus 1/5 rather, will give you negative 1. Okay? Then we have now 0, 0, 1, negative 1. Then the last row now, R3 minus R4. 0 minus 0, 0, 0 minus 0, 0. 1 minus 1 is 0, then negative 1 plus 1 is 0. Okay? So, class, identifying now the values of K1, K2, and K3. So, each leading one here does shades to a constant, no? And that constant refers as the scalars K1, K2, and K3. For the first column class, this will be K1. So K1 equals 2. Then for the second column, we have K2 equals negative 1. Then we have K3 equals negative 1. Then the last row class, it is a true statement because 0K1 plus 0K2 plus 0K3 equals 0. Okay? So this makes class the system is an independent or consistent system. And as you can see, there's 1, 2, V2, whose components are 1, 0, 1, and vector V3, with components 2, 1, 3, span the vector space R2. So as you can see, class, we have now a different composition of your vector. We have V1, V2, V3, and without now the vector W. It means that vector W here is an arbitrary vector, and it will have components, the components of the real numbers as its components. Okay? So let us classify now vector W contains X, Y, Z. Of course, where X, Y, Z here are any real numbers. Okay? So this is what we're going to do first class. Identify the component W. You know, it's not given it's not given the problem, but you can define it as vector W whose components are X, Y, Z. So we can use also other letters class of the alphabet. No? You can use A, B, C, if you want. And then when you define now if this given vector span the vector space RQ. So we have now the formula using the standard equation V1 K1 or K1 V1 plus K2 V2 plus K3 V3 equals vector W. Okay? So K1, then you have your V1 2, 1, 3 plus K2, then you have it should be 1, 1, 2. Then K2 you have 1, 0, 1. Then K3 you have it as 2, 1, 3. And vector W is X, Y, Z. Okay? So for now your matrix here. So first column will be components of your vector 1. So 1, 1, 2. And then you have second column will be components of your vector 2, 1, 0, 1. Then you have column 3 will be components of your vector 3, 2, 1, 3. Then you have the last column that is component of vector W, X, Y, Z. Take note that the letters here, variables X, Y, Z are any real number. Okay? So we're gonna do transforming the matrix into RREF or reduced row echelon form because we're going to find K1, K2, and K3 class. Okay? So what will then be the operation here? So we've already leading 1 in the first column. So we go now to the other elements, which are 1 and 2. So let us transform them to become 0. So the operation is using now leading 1, row 1, then subtracting 2, row 2. Then for row 1, I will multiply this by 2, then subtract it to row 3. Okay? Then copy now class the first row because we will not transform the first row. Okay? But with regards to second row and third row, using this operation now, it will be 1 minus 1 is 0. Then 1 minus 0 is 1. 2 minus 1 is 1. Then x minus y. You just write here x minus y. Okay? Next, you have now 2 or 1 minus 5. So 2 times 1, 2 minus 2 will be 0. 2 times 1, 2 minus 1. That is 1. 2 times 2, 4 minus 3 is 1. Then you have this as 2x minus 6. Okay? So we have already the followed the standard form of row echelon form in column 1. Or reduced to echelon form in column 1. Okay? So we go now to second column. So where we have to transform it into 0, 1, 0, right? So let us use the leading one. We have already leading one in the second column. Then let us transform now 1 first row and the element 1 in the second and third row to be 0. So using the operation row 1 minus row 3. Then you have, or you should say row 2. Then row 2 minus row 3. Okay? So what is it now? 1 minus 0 is 1. 1 minus 1 is 0. 2 minus 1 is 1. Then you have now x minus quantity x minus 1. Okay? So do not simplify this yet. That's okay? So we go now to second row. So just copy 0, 1, 1, x minus 1. Okay? Then for the third row now, use R2 minus R3 operation. So that is now 0 minus 0 is 0. 1 minus 1 is 0. 1 minus 1 is 0. Then you have now x minus 1 minus 2x minus 8. Okay? So is this now an RRTF form? Yes. Okay. Let us now define the K1, K2, and K3. So as we all know already that each column corresponds to the constant K1 as an equation. So each leading one corresponds to K1. Then the second column will be K2, then third column will be K3. So as you can see, we have now, if we're going to transform this as an equation, it will be K1 plus K3 equals x minus x, that will not be 0. Then negative 1 times negative will be positive 1. Okay? What about the second row? This will be K2 plus K3 equals x minus y. Now, with regards to the third row, this transforms to, or this will be an equation, linear system. So that is now 0, K1 plus 0, K2 plus 0, K3 is equal to x minus 2x, will give you negative x, then negative y plus z. But, as you can see, we have here the last row having a false statement. And that makes this, the system is now inconsistent. Okay? So with that, it has no solution. So we have found no values for K1, K2, and K3. And with that, we can say now that the vectors V1, V2, and V3 does not span the vector space R3. Okay? Using the arbitrary vector W. Okay? So, then it's your final answer.